Welcome to our IT 101 session for the last quarter of 2021. My name is Brad Steele, and I'm the Senior Director of Unified Communications for the Commonwealth of Massachusetts, and I am a past president of NASTD. While I was president a couple of years ago, I was reading through the NASTD Constitution, and there was something that just popped out to me that seemed of interest. In the Constitution, Article 1, Section 2, under the purpose and goals, the second goal stated was engage in programs for training, education, and development of technology professionals from all areas of state government. And that was something that I thought that we could do a little bit better on at the time. And so I started doing monthly sessions, IT 101 sessions, as I called them, where we speak with industry professionals and we find a topic of new technology or understood technologies, and we get with the subject matter expert from our corporate community, and we kind of get some basic information so that people can be better informed and at least have a starting point for their discussions and their networking on these topics. We started off with hyperconvergence, which at the time we thought was hyperconfusion. So that was what kicked it off, and what really struck my brain as an opportunity to start these sessions. And we did one for the first 6 months. We did one a month, and we've switched to a quarterly fashion since then. So if you have not had a chance to see our past subjects, you can go into the NASTD website at nastd.org, and you can look those up. You should be able to find those pretty easily and take a look. So in the annual meeting this year, we reached out to the corporate affiliates and asked for some guidance on topics of interest, and I'm very pleased to say that we've been receiving a lot of insights and a lot of ideas. And so for the first one we're doing this quarter, our session is going to be artificial intelligence, AIOps. And our subject matter expert for this session will be Tim Tang, Director of Enterprise Solutions at Use Network Systems. So welcome, Tim.
Thank you, Brett. I look forward to our conversation.
Excellent. And so for those of you who haven't seen the videos yet, I have a kind of a standard set of 10 questions. I mean, they vary a little bit based on the technology itself, but a basic set of 10 questions that I hope will bring out the like I said, that foundation of knowledge that we need to be better versed in AI. So Tim, simple start off question, or maybe not so simple, but the base question: what is AI ops and what is it used for?
AI ops really speaks to being able to use your data to try to achieve some additional operational efficiencies. So what's kind of remarkable is that we're actually, in many cases, sitting on enormous amounts and volumes of data. And the challenge has always been, how do we get value out of this? How do we get some actual tangible benefits from this data? And so when we talk about AI ops, what we're trying to do is we're trying to use the data that's available to us, analyze it to understand how things are operating or not operating, and look for ways to optimize the user experience or the application performance.
Okay. And so what is the difference between AI and machine learning?
That's a really good question, because it brings up maybe a philosophical issue. I think if we were to be very precise, I think many would make the argument that artificial intelligence really doesn't quite exist yet. I mean, certainly there's been many advances in terms of our ability to, but true artificial intelligence, where we have self-imposed learning or self-initiated learning, we're not there yet. But unfortunately, when we look at the markets, what we call AI, or what we refer to as artificial intelligence, is quite often confused with machine learning. So if I were to characterize it, yes, there is a difference between the two, but I think from a vernacular perspective or vocabulary perspective, they're used quite interchangeably.
Okay. And as a state entity, how might I use AI to help improve things that I do in the Commonwealth of Mass in my case?
Well, it really speaks to the amount of data. That's a really interesting question that has many potential answers. I think first it begins with, what are we trying to accomplish? What services are we trying to provide to our constituents? And what data is available to support those services? And then to what extent can we improve the constituents' experiences as well as the state employees' experience too as well? So maybe some examples to think about. There's an enormous amount of demographic data that we might have. There's an enormous amount of salary, financial data, whether it be in businesses or homes and the like. When we talk about AI ops, what we're trying to do now is trying to figure out ways to kind of improve the end user experience as, again, as it relates to the constituents and the employees. And that could be manifest itself in kind of a variety of different ways. It might be something along the lines of looking at common issues, reviewing, for example, call logs to certain agencies and saying, what are constituents calling most frequently about, and what issues or what problems are most commonly occurring, and then to proactively try to address and solve those problems in a more efficient manner. It might be the idea of reviewing several months of call logs, understanding that these top 10 questions or issues keep reemerging over and over again, and then proactively posting those answers to a website to make it easier now for constituents to find the answers that they're looking for. Well, what we're trying to do is we're trying to use the data to inform our understanding of the problems and then proactively solve those problems before they become a problem.
And I'm assuming that when you say that rather than good old-fashioned manpower, you're having a computer do that for you, right? So as opposed to having somebody sit and look at a call log and analyzing every call, and then making a recommendation, that there's a machine doing that or a computer that's doing that for you.
Yeah, there's a lot of other kind of adjacent technologies that are improving our ability, and one of them is natural language processing, right? The ability to basically take either, to actually take audio recordings of actual calls, or even do transcripts and analysis of what people are talking about and what problems they're talking about too as well. So there's a number of different ways, or just even munging the data associated with call tickets and being able to understand which problems keep reoccurring and how might we proactively solve those problems before they become problems.
Excellent. So my next question starts with, what benefits does it add? I think you've kind of covered that a little bit, but what possibly could, putting AI in place, what could that possibly replace or supplement in our existing environments?
Well, in an ideal scenario, we want to solve problems that continue to reoccur, repetitive tasks in many cases. So if we can get some understanding of what the more popular or the more simple or common issues and problems are, and find a way to automate their resolution, then that leaves our employees to focus on the more important problems, or the more, say, challenging and more complex issues too as well. So that they're not answering the phones, or they're not working with customers on really simple tasks, but really the more complex tasks. It improves the user experiences for the employees. It improves the user experience for the constituents too as well, in that they get their answers quicker, and they get to take advantage of the fact that other constituents have called before about the same problem, and now they have the benefits of the more readily access to those issues, to those solutions too as well. So when we're looking at AI ops, there's an element of constituent satisfaction, employee satisfaction. There's also the ability to kind of look at patterns of behavior, and use those patterns of behavior to detect problems before the problems occur. And so what I mean by that is, if you look at, for example, call volume rates, or if you look at traffic rates for constituents coming into a facility, we can look at those patterns, the people counting, the number of people coming on a per hourly type basis. And we can look at changes in those patterns as indicators of other potential problems. So if there's a dramatic drop off in the number of constituents coming into an agency office, that might be a flag that says, has something changed? Is there something wrong with that agency office that suddenly now people are no longer coming to the office? Is there an issue that needs to be resolved? These are the kinds of warning flags or indicators that might allow us to fix problems before we actually get a warning message of, hey, there's a problem, an issue with the parking lot, or there's an issue somewhere else in the facility.
Cool. See, now you said traffic, and I all of a sudden thought, oh, it's going to cut down my hour-and-a-half long commute into Boston every day. Oh, darn,
Well,
wrong kind of traffic.
no, actually, when I think about, and it's quite remarkable when we look at government agencies, state government agencies, and their use of AIOps. It's the traffic is one of the common implementations that we see in terms of looking at flow volume rates, and then looking to optimize the signaling to kind of optimize traffic flow within a city too as well. And so it absolutely is being employed to try to improve traffic conditions throughout the city, throughout the suburbs.
So, in looking at artificial intelligence, what are some of the use cases that states might use? What are the things that they might implement AI for?
Well, we're looking for areas where data can actually inform and using correlation, data analysis, we can actually anticipate kind of problems and issues before they happen. So we've talked quite a bit about like constituent facing and employee facing activities. There's quite a bit on the back end that we can actually look at too as well. And what I mean by that is looking at the infrastructure that's actually supporting the agencies, looking at the internet connections that are into the facilities themselves in terms of their availability, the amount of data that's coming through, looking at how reliable the internet connections are, looking at let me start over again. Let me have you ask that question again, because I don't think we actually want to go that direction. That's probably a little bit too esoteric. I think we want to probably stay with just more of the kind of the simple applications and the simple usage. So maybe what we do is we'll focus on like agency satisfaction scores. We'll look at kind of employee records in terms of training and those kind of elements, particularly for NAST, AST. So maybe we'll take it down that path, and then we'll see how we can do those kind of things.
Okay. So as I look at artificial intelligence and think about possibly implementing it, what are some of the use cases that I would want to look at?
So what we're looking for are situations where data can actually give us some insight as to kind of what might be happening behind the scenes. So a very common use case might be looking at, for example, employee training, looking at the training curriculums that employees have undergone, and then correlating that data with constituent satisfaction. So we'll see that in some certain cases, constituents might rate certain employees based on their performance higher than others. And then we can take a look at that employee's background and see what kinds of training programs and training curriculums have they gone through, and what kind of training curriculums actually make the most impact to an employee's performance. And then we can use those insights to create more effective training curriculum kind of for the employees. So the idea here is to say that we want to look at the outcomes. We want satisfied constituents. And then we want to look at the contributors to those outcomes. It may be employee performance is a very key element and aspect of constituent satisfaction. And then we want to look at contributors to that employee's performance, such as their training curriculum and their years of experience, and also the roles and responsibilities that they may have had. And each one of these kind of different data streams might be able to inform and give us insight as to kind of what would create that ideal constituent experience.
So going back to something you had said earlier, you can take the information from a call center that you're taking certain number of questions on a certain item, a high item, and where the training has been, and say, hey, we don't have enough trained employees to answer these questions, and you could kind of correlate that together and come up with a plan to better educate your staff.
And what's really interesting there is that we can actually look and start to address the nuances of specific questions too, right? It could be a matter of the actual topic might be confusing to the employees. It might be the way the employees are explaining the answers to the topic, or it may be the nature of the questions that the constituents are asking. I mean, in each of these different cases, we have the ability to leverage the data, see kind of where the problems may be occurring, and be able to identify what an appropriate uh, resolution might be.
Excellent. All right, so now I'm going to turn on my business hat for a few minutes. So if I'm looking to put AI in place, what do I have to think about? What hardware, software, or what other elements is it that I need to procure?
Well, when we think about that, there's many ways that AI ops gets implemented. I think there's a lot of what we're looking at depends on kind of what situation or what problems we're trying to solve. We'll try to tackle this maybe a couple of different ways. One is to say that when it comes to AI ops, a very common area where it gets employed is in kind of self-healing networks. So if we think about all the back-end infrastructures, the systems that might be used to support a state government's ability to serve its constituents. And by that I mean, all the networks, all the servers, all the applications, all the different technology pieces and components. Some of the first things as we think through are we're going to want an area that can be actually where we can automate the management of that. And that just means that if an application were to crash or if a server were to go down, we have the automatic ability to recover from those kind of situations. So when we think about AI ops specifically in the context of self-healing networks to try to improve our ability to maintain our infrastructure to support our constituents, then we need components, everything from the ground up, the individual switches and the routers and themselves, all the way to the servers and the applications. We want components that can be self-healing, where we can automate the restart in the event of an outage, or even be able to anticipate based on log data, based on error messages that might be coming up saying that, hey, for these components of the infrastructure, these kinds of messages may indicate in a predictive type manner that we're going to have an outage in 2 days or 3 days, and then proactively and during some off-peak moment try to recover from that so that we can eliminate whatever those concerns might be. So when we think about AI ops and how do you buy it is really the question. It maybe comes down to a question of first of what problem we're trying to solve, and then what elements are going to be involved in solving those problems, and what kinds of controls do we need in place so that we can automate the resolution of those problems. So that might be kind of one way to think about it in that type of context.
And so to kind of further that question, so is it normally something that you buy physical hardware for and put in your own data center, or is it more of a quote cloud-based offering that you have a service for?
You have options to do either. What I commonly see is that there are a number of cloud-based services. I think your earlier questions of what kind of changes have been taking place that suddenly kind of enable or have created this desire for AI ops or the ability to implement AI ops. A lot of the cloud solutions have opened up the ability to get on-demand resources at a very cost-effective type component. Some of the challenges when we think about AI ops is just an enormous amount of data that may be involved that we are trying to do some rather complex analysis in order to try to get the correlations that we're looking for in order to be able to take the predictive actions that we're looking to predict. So in that kind of context, yeah, there may be a lot of cloud-based services are often a very cost-effective way of addressing the storage requirements, the processing, the compute cycles too as well.
All right, and I know October is done, so Cybersecurity Month is over, but I still need to ask, what concerns do I need to have around security with AI?
I think there's it is like everything else. When we think about how digitally dependent as we become on this, your question about cybersecurity is very appropriate. We need to think through what cybersecurity defenses are going to be put in place. Because if we want to have self-healing networks, we don't want to have bad actors coming in and disrupting the network with false alarms and the like. So the protection around this is becoming paramount. In order for AI ops to be able to bring the efficiencies, we need to protect it from the liabilities of bad actors misbehaving inside of the network, seeking to cause disruption. And we've seen quite a bit of that with ransomware attacks, cyber attacks, and the like. And so a robust infrastructure to protect that. And it when we talk about, as to the earlier question about how cloud services have enabled a lower cost access to storage and compute capabilities, well, it also has introduced an expanded threat surface that needs to be defended and protected too as well. But this is an area that's kind of well understood, and there are good solutions in place for that as well.
All right. The answer to the next question can't be it depends. How long does it take to implement AI?
How long does it
depends.
I was thinking perhaps, yeah, and I'll respect the fact that it depends doesn't really help us very much. Perhaps a more helpful answer is to set expectations of what AI ops often entails. When we start down this journey of AI ops, it is an iterative process. We take a look at all of the data that's available to us. We do some initial correlations, and then we attempt to do an intervention, an automated type of intervention, and then we look at the results and we see how desirable or undesirable the outcomes are. And then we repeat this process. Based on that new set of outcome, the additional data, then we go through the process again, and there's a tuning process too as well. So I think there's maybe two pieces to the puzzles to think about. One is to have the proper expectations and understandings of how AI ops works. It won't be perfect the first time you try it. It will likely be an iterative process where you are tuning as the opportunity presents itself, your actions and your analysis to refine the correlations and refine the actions that you're going to take based on those correlations too as well. The second piece I would say is that AI ops is something of a black box, but in that many don't understand the novel algorithms that run inside it that give you the correlations and give you the pattern matching. Yet at the same time, there there is a kind of a robustness to or a credibility factor to think about with the numerous providers that are out there. At the end of the day, we're gauging them on their ability to do correlations. And so what I see commonly happen is as a vetting process is that you take a significant portion of the data and you give it to the various vendors that you may be looking at, allow them to do their work, allow them to train their AI engines to come up with the correlations. And then once they've done that, let's say you save 20, 30% of the data that you don't give to them, then you test the effectiveness of their algorithms and their abilities to basically anticipate problems on the remaining 20% of the data that you didn't give to them. And so it's these kinds of processes where you can use to ferret out who's got a reputable solution in place and who does not. So I think it's one of those things where it's one, be ready for kind of a journey of sorts where you're going to get started and it's going to get better and better. But at the same point, you also want to vet the providers that you're working with and saying, are you able to at least achieve some of the basics here so that you're working with the right players.
It sounds like renovating my house. It's like it never ends. You just keep going, and as soon as you're done, you start over again.
I share your pain.
So, how does the cost structure usually work? Like we said, how do you buy it, but how do you pay for it?
In many cases, it's in the background, and what I mean by that is the efficiencies that vendors achieve through AI are often basically baked into their business model. So if they're achieving an ability to provide operational services with fewer people, you just see a lower monthly cost. If they're able to provide tangible cost savings, sometimes in some cases there might be some innovative models where it's a portion of those shares. But generally speaking, it's not a line item that says AI ops costs this amount for this capability. It's more of a business services outcome. You're buying a capability. So if it's network services, or if it's a loyalty program or data management, you're paying a monthly service for a, a, an application portfolio, if you will. And it's the AI elements of it and aspects of it are inherent into that monthly fee.
Okay. Final question. Believe it or not, we're there. What else do I need to know? What are we forgetting?
I think the what's interesting here, and what we haven't talked about, is that the thing about AI ops is that it's quite powerful in terms of what it as we look at AI machine learning, and then looking at AI ops in terms of its ability to get efficiencies, improve constituent as well as employee satisfaction. But one of the flip sides of it is it uses a lot of data. It uses a lot of constituent data, and that introduces a number of privacy concerns too as well. So as we start thinking through the benefits of AI machine learning, big data analytics, AI ops, those components then come into the depending on what we're doing here. I mean, if we are from an AI ops perspective, if we are talking about maintaining a network infrastructure, now we're talking about log data and alarms and munging through volumes of data. That's one scenario. If we're talking about looking at trying to anticipate and improve constituent and satisfaction, in many cases we are using a lot of sensitive data that needs to be handled in an appropriate manner, and that we need to anticipate the liabilities associated with when things go wrong too as well. So it's a very powerful element, opportunity to improve things, but it also comes with certain liabilities as it relates. We have already talked about the cybersecurity, and potentially the data privacy raises a number of data privacy issues as well.
Excellent. All right. Well, that ends our informative session. So thank you very much. It's amazing. You hear terms, whether it's cloud or AI and those things, and it kind of has this broad meaning, and kind of honing it into some of the individual use cases kind of gives it a better focus in my mind, a much better understanding of how we're going to be using it, or should be using it on a day-to-day basis.
I would say that statement actually also reminds me, another part of the answer is that we also need to think about, the biases that may be latent inside of the data, right? So there is always a need from a human perspective, a human element, for us to intervene in many cases. The ideal optimizations that you get from data analysis don't necessarily line up with what our society, or what we as a society might agree with. And so there is always going to be a human element that is going to be necessary when it comes to AI and machine learning.
Wow, very cool. Well, thank you again. Again, Tim Tang from Use Network Systems. Thank you for your time. Thank you for your insight. And for those of you who are interested in this content, again, NASCD.org has additional information that you can look through. And my name is Brad Steele, and I'm with the Commonwealth of Massachusetts, brad.steele@mass.gov. So you can reach out to me, and if you have any other questions, or if you want to get in touch with Tim, I can put you in touch with him. So thank you very much for watching, and see you all next quarter.